Okay, let's continue the discussion of a quadratic polynomial. From last computation, we know that if we have fx equal to ax squared plus bx plus c, it's a general form, a standard form of a quadratic polynomial. Here we always assume a is not equal to 0. It really contains a second order. Then let h be negative b over 2a, and k is 4ac minus b squared over 4a. If you examine it, it's also actually the value 1 x is equal to h. It is a value 1 x is h. And when you have this h and the k, you mainly just remember this h. The k formula, if you consider it's too complex, you can just recall it as f of negative b over 2a. Then this fx can also be written as a times x minus h squared and plus k. A times x minus h quantity squared and plus k. This formula comes from the process of completing square. And in this formula, the point hk is called the vertex. And the line x equal to h, the line x equal to h is called the axis of symmetry. The axis of symmetry. Okay, so vertex is a point, axis symmetry is a vertical line. And if a, the coefficient of x squared, if a is positive, the graph of this quadratic polynomial opens up. If a is negative, the graph of the quadratic polynomial opens down. Okay, so let's draw them. Okay, assume you have them. Then this point is hk, and this is a rotation, the symmetric axis, and this is a case 1. A is a positive. This is case 1. A is negative. Okay. Okay, so this is the general case. Now let's try to do some examples. So assume we have this function, negative 3x squared plus 6x plus 1. And from this formula, we can see that a is equal to negative 3. It's less than 0. So the graph opens down. Okay, so it looks like, the graph looks like this case. And then you can find the h negative b over 2a. Negative sign is part of the formula, so you always copy negative sign. B, what is B? B is a 6. 2 is 2. A is negative 3. A, B, C contains the sign. So negative sign cancel. 3 times 2 is 6. 6 over 6 is 1. So the H is 1. H is 1. What is K? K, of course, you can recall this complex formula, or you just memorize it as f of 1, f of h. So you got a negative 3 plus 6 plus 1 is equal to 4. So the vertex is 1, 4, and the axis of symmetry is x equal to 1. You just get the x coordinate of the vertex. Okay, so that's the vertex, axis of symmetry, and the direction of opening, open up or open down. Okay. Okay. Now let's try to study its intercepts. We always know that the y-intercept, is the value of f at x equal to 0. So y-intercept, let x be 0, you only find the y, f of 0. The x-intercept if exists, are found by solving the equation ax squared plus bx plus c equal to 0. So technically, the x-intercept are the solutions of fx equal to 0. X-intercept, y is 0. Y-intercept, x is 0. Okay? So they are the intercept. And with the careful computation, we can see that there's rules about x-intercept. Of a quadratic rules of x-intercept of a quadratic function. Number 1, the discriminant, if the discriminant what is discriminant? B squared minus 4ac. If the discriminant is positive, then the graph of fx equal to ax squared plus bx plus c has two distinct x-intercept. Okay, it has two distinct x-intercept. So the graph crosses the x-axis in two places. Okay, so discriminant positive, you have two distinct intercepts, and the graph crosses the x-axis in two places. It's like this. Crosses two places. This corresponds to the b squared minus 4ac greater than 0. And second, if the discriminant b squared minus 4ac is equal to 0, then the graph of fx equal to ax squared plus bx plus c has one intercept. So it touches the x-axis at its vertex. At its vertex. So what does this mean, touch? See here. Like you place something on the floor, or you attach something to the roof. So this is a touch. And for both cases, one is open up, one is open down. But for both cases, this unique intersection point is always a vertex. Okay. Third case, if the discriminant b squared minus 4ac is negative, then the graph of fx equal to ax squared plus bx plus c has no x-intercept. So the graph does not cross or touch the x-axis. Does not cross or touch x-axis. So this is one of the case. When A is a positive, this case corresponds to the case corresponds to the situation discriminant is negative. It is off the x-axis, above the axis totally, and let's use a minimum place to sketch it. It's like this. This is a positive discriminant negative. This is a negative discriminant negative. A just determine the direction of opening, open up, open down. Discriminant negative just means when you sketch it, it is either totally above the x-axis, like this case, or totally below the x-axis. Above or below, it depends on the sign of A. A positive, it has to be totally above x-axis. A negative, it has to be totally below the x-axis. Okay, that's the intercept, vertex, and graph, and discriminant. So in this case, you can see that cross this way, or this way. This is a cross. You have cross case, you have touch case, you have a no intercept case. It is totally determined by the discriminant. greater than 0, equal to 0, and less than 0. Greater than 0, equal to 0, and less than 0. Okay? So that is the summary. Okay, let's see the example. Okay, so we still have this function. Fx is negative 3x squared plus 6x and plus 1. Plus 6x plus 1. And first, we want to use the information we already know. We know the vertex. This is the example we had at the beginning of the lecture. We know the vertex. We know the use the information from the last example and the location of the intercept to graph fx. So what is the information from the last example? The information from the last example is vertex axis symmetry and opening. Okay, so let's do it one by one. So the vertex is, we got it, it is 1 and 4. The axis of symmetry is x equal to 1, opens up. Sorry, opens down, it opens down. Did I write it? Opens down, yes. A is negative 3, it opens down. Okay, so that's information from the last example. And the location of intercepts of the graph. Well, let's see. Whenever you see the intercepts, it has two types, x and y. When you talk about the y-intercept, the y-intercept is f of 0. Y-intercept is the value of f1 x is equal to 0. So you let x be 0, 0, 0, 1. So the y-intercept is 1. It is a single point. Y-intercept is 1. The x-intercept we do have the quadratic formula. Remember that when we have this a x minus negative b over 2a, this is h, and plus 4a c minus b squared over 4a equal to 0. Right? So remember that this is h, this is k. And you move this to the other side. You move this term to the right side, b squared minus 4ac. You get a negative sign. Negative sign will exchange the order. And you divide the equation by a. And then you take square root, you choose positive, negative, plus or minus sign, and you will get get this formula. This formula is called the quadratic formula. And this formula is used to find the x-intercept when it makes sense. Okay, so we had this process in the past section. Okay, so now let's check, and also this is the reason why why we have to discuss this discriminant b squared minus 4ac. Positive, then you will have plus or minus, you have two roots. Equal to 0, you have two repeated roots, so it looks like you only have one root. And a negative, square root of negative number does not make sense, so there's no solutions. Okay, back to our problem. B is 6, A is negative 3, C is 1. So you will have one solution corresponding to plus, one solution corresponding to minus. So it's a negative b plus square root of b squared minus 4ac 2a. Okay, so it's negative 6 plus 4 root 3 over negative 6. And the other one, you just change this middle sign from plus to minus. All other parts are identical to the last computation. Okay, so here we just do the plug-in. From this example, we assume you use some calculator. You will see that this is approximately is a negative 0.15, and this one is approximately 2.15. In the exam, of course, you cannot use calculator. Here we just try to demonstrate, and we want to get the location. You see here, the location of intercept. So we must know the precise the estimation, not just these symbols. Okay, so what we have a vertex, symmetry, y-intercept, x-intercept. Now let's try to graph it. It opens down, so you don't have to draw a lot to the bottom. And the y has 4. Y is here. 1, 2, 3, 4. So this is a vertex. When it opens down, the vertex is a maximum value because it opens down. So vertex is a maximum value. Okay, and the y-intercept is 1. The y-intercept is 1. So you have this point. And the one, you see here, 1 x-intercept is negative 0.15. Let's just estimate, negative 0.15. And the other one is 2.15. It's here. Okay, so we just try to it's not triangle, but it's hard to make it smooth. So again, it's not a triangle because I don't get the precise location of a 0.15, so it's bad. Right. Okay, so that's the graph of the function. Sketch. And from here, let's see the B, part B. Okay, so to sketch the graph, you determine the vertex, you determine the rotation axis, you determine the axis of symmetry, and then you get the opening, so you have up and down. And these 3 points just tell you how to sketch the graph when it crosses y-axis and x-axis. Okay, so vertex, opening x, y intercept. See, 1, 2, 3, 4. Those 4 information will give you the rough idea about the graph. Okay, so that's more or less everything you need. And y-axis f0, x-axis quadratic formula. If it's too general, if you have a general quadratic function, you have to use quadratic formula. Okay, it's here, negative b plus minus square root of b squared minus 4ac, and divided by 2a. And this formula is on page 293. You can find the formula. Okay, and second, determine the domain and the range of f. F is a quadratic function without other or without additional condition. The domain of f is always, you can write it like R, or you can write like negative infinity to positive infinity, or you just say the set of all real numbers. Okay, so either works. You can just either write R or negative infinity, positive infinity, or you use a verbal definition, the set of all real numbers. Okay, this is the domain. And the range, let's see. Whenever this quadratic polynomial opens down, it has a maximum value. It's from negative infinity to the maximum value. So the range is from negative infinity to the highest point. The highest point is the y coordinate of the vertex. Vertex is the peak. Okay, so it's a 4. So this is a range. Okay, now let's see if it opens up. Range is from k to infinity. If it opens down, hk, remember that we always use hk to denote the vertex. K is f of h. Then the range is from negative infinity to k. And for both cases, the domain is always a set of all real numbers. Okay, and that's the domain, the range, and the monotonicity, the increasing, decreasing. F is increasing. And where it is decreasing. Okay, now let's check the graph. The axis of symmetry always split the graph into 2 pieces, or into 2 sides, left and right. For this case, you can clearly see that on the left side of the axis of symmetry, it's increasing. On the right side of the axis of symmetry, it's decreasing. So on the left side, negative infinity to 1, f is increasing. On the right side, 1 to positive infinity, f is decreasing. Okay, so just check this graph, you will clearly get the answer. Right? Okay, so and that's more or less the basic information about the quadratic function. Okay, let's see another example, another similar example. So we have x squared minus 6x and plus 9. Graph f by determining whether the graph opens up or down, and by finding its vertex axis of symmetry, y-intercept and x-intercept. Okay, so you see here it's the same. It's a identical process. We have vertex and opening x and y intercepts. Opening the vertex x y intercept, and axis symmetry is together with a vertex. Okay, so a is equal to 1 from this case, so it's positive. The graph opens up. So it's an obvious fact, but if you see the problem in the exam, you have to write down this statement. You cannot say it's so obvious, we keep this in mind. In the exam, you cannot keep all the facts in mind. You must write them down, okay? So because this is part of the question, determine whether the graph opens up or down. Because it's positive, so the graph opens up. And the vertex h is negative b over 2a, and f of negative b over 2a. Okay, what is b over 2a? b is negative b over 2a. Is negative, b is a negative 6, 2 times a. So this is a 3. So f of 3, so it's a 9 minus 9 3 squared. 3 squared is 9. 6 times 3 is 18. Uh, 0. That's equal to 0. Right? 9 plus 9 is 18. 18 minus 18 is 0. Okay, so the vertex is 3, 0 is the vertex. And x equal to 3 is the axis of symmetry. The axis of the symmetry. Okay, so let's move it here. The axis symmetry is x equal to 3. For y-intercept, f of 0. Y-intercept f of 0, 9. You let the x be 0, 0, 0, 9. X-intercept is the solution of x squared minus 6x plus 9 equal to 0. And this one, you can fact it as x minus 3 squared. So x is equal to 3. There's only one. Actually, there are two repeated solutions. There are two repeated solutions. So x-intercept, there's only one x-intercept. Okay, then we sketch the graph. Open up. One, two, three. Vertex. When it has just one solution, the graph touches the x-axis. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Axis of symmetry. Axis of symmetry. And the vertex is a 3, 0. Again, it's not a triangle, just because my art is bad, so I cannot sketch it beautifully. But it's not a triangle at all. Okay, so open up, vertex, y-intercept, and the axis symmetry. Okay, then that's part one. Part one, you have five points. Point 1, opening, vertex, symmetry, y-intercept, x-intercept. Domain range. The domain is R, the set of all real numbers. The range, remember we mentioned if the graph opens up, it's from vertex to infinity. Including the vertex. Here I think we got some small error, so this is including. Yeah. Okay, so this from 0 to infinity. It's about vertical. Range is about vertical values. And C, the increasing, decreasing. The same thing, the axis symmetry split the graph into left and right piece. The left piece you will see it's decreasing, right piece it will be increasing. So on the interval negative infinity to 3, f is decreasing. On the right piece, 3 to infinity, f is increasing. Okay, so that's a problem. And in this part, you have a repeated term. And let's see what is the discriminant. B is negative 6 squared minus 4. A is 1. C is 9. Negative 6 squared is 36. 4 times 9 is 36. It's 0. Okay, so it's the same thing. If you compute the discriminant, you will get a 0. If you factor it, you will get a repeated solution. They mean the same thing. Okay, so the last example, we have a positive discriminant. So you have two roots, two x-intercepts. The graph crosses the x-axis. This example, the b squared minus 4ac discriminant is equal to 0, there's only one x-intercept. The graph touches the x-axis. Okay. And in the next example, we will see what happens if the discriminant is negative. To x squared plus xn plus 1. Okay. Same question. We are going to have this list of the information 1, 2, 3, 4. So the opening a equal to 2 positive, the graph opens up. B, the vertex negative b over 2a, f of negative b over 2a. The vertex. Let's see, negative b over 2a is equal to negative b is 1, a is 2, so it's negative 1 over 4. And f of negative 1 over 4, negative 1 over 4 squared is 1 over 16, plus negative 1 over 4, and plus 1. So this is f of negative 1 over 4. F of negative 1 over 4. So you get negative 1 over 4, f of negative 1 over 4. So the vertex is negative 1 over 4, 7 over 8. Okay, and 3, the axis of symmetry is x is equal to negative 1 over 4. Whenever you see the x coordinate of the vertex, it will give you the axis symmetry. For y-intercept, y-intercept is f0. Y-intercept f0, x is 0, y-intercept is 1. X-intercept are the solutions of the function equal to 0. Remember, we have discriminant b squared minus 4ac. b is 1, 4, a is 2, c is 1. b squared, 1 squared is 1, so it's 1 minus 8, negative 7, less than 0. The equation has no solution. The equation has no solution. When the discriminant of the quadratic equation is negative, it has no solution. No solution, no x-intercept. Okay, so with all these informations, let's sketch it. Okay. This is 1 half, 1 over 4, 3 over 4, 7 over 8. It's a negative 1 over 1 half. This is negative 1 half. This is negative 1 over 4. So negative 1 over 4, 7 over 8 is here. The axis of symmetry is like this. opens up, no x-intercept, y-intercept is 1. It's like this. Okay, so it's off, it does not intersect the x-axis, so it's off the x-axis. Okay. Okay, then let's see what is the domain. The domain is R. No restriction. The domain of quadratic polynomial, the quadratic function is always R. The range is, it opens up, so it's from the y coordinate of axis to infinity. Mm, 7/8 to infinity. So 7/8 is from here. So domain and range, increasing, decreasing, similar thing. It split the axis symmetry, split the graph into left and right piece. So on the negative infinity, -1/4, f is decreasing. On -1/4, half to infinity, f is increasing. Right? So that's similar stuff. And we do 3 examples, 3 similar examples, because there are 3 parallel situations. You have 2 x-intercepts, 1 x-intercept, and no x-intercept. So that's a purpose we do the all 3 similar examples. Okay. Okay, so when we have an equation, we can determine its vertex, and we can find the axis symmetry. We know it's opening. We find x-intercept, y-intercept. So from the algebra, like the formula x squared, y squared stuff, from the algebra we can get some geometry, vertex, the point, and we can also go backward. Assume we know the vertex and some other points. We can determine the equation of the quadratic function. Okay, so remember, the quadratic equation can have the standard form ax squared bx plus c. It can also have this vertex form, a times x minus h quantity squared plus k. hk are the coefficients of coordinates. hk are the coordinates of a vertex. Okay, so let's see. Determine the quadratic function whose vertex is 1, -5, and whose y-intercept is -3. Okay, and graph it. Okay, well, let's see. Whenever you have vertex, the function is fx equal to a times x minus 1 squared minus 5, -5, plus -5. Whenever have the vertex, you will determine h and k. that is a very strong condition. It directly gives you two quantities, h and k. So you only need to determine this coefficient a. You only need to do this stuff. So how do we determine this a? You use the other condition. The y-intercept is f0. So f0 is equal to -3. You check it. So when x is 0, 0 minus 1 is -1. -1 squared is still 1. So 1 times a is a minus 5. So you get -3 is equal to a minus 5. So you move 5 to the other side, you get a is equal to 2. A is equal to 2. So the equation is 2x minus 1 quantity squared and minus 5. Right? So it opens up. It opens up with vertex -1, 5, and with a y-intercept -3. One, -5. 1, -5. So -5, -4, -3. And this is axis asymmetry. It opens up. So we only sketch it. So that's it. And that's it. Okay. So whenever you have the vertex, again, it's a very, very strong condition that gives you h and k, and you use additional condition. Whatever additional condition, you can determine this a. Okay. The final thing we actually already discussed. Let's try to emphasize it here. A is negative. A is negative. The graph like this. The graph is like this. Then f has the maximum value. X has a maximum value. At where? At the vertex. F will have maximum value at the vertex. The maximum value, the value is f of negative b over 2a. It's just a y-coordinate of the vertex. It's maximum. 2. If a is positive, the similar situation happen. F has the minimum value at negative b over 2a, and the minimum value is the value itself, f negative b over 2a. Again, is the y-coordinate of the vertex. Okay, so that's we mentioned this before, but let's just emphasize it here. Okay, so let's do one example, a quick example. So assume our function is x squared minus 4x and minus 5. A is equal to 1 positive, so f has the minimum value at negative b over 2a. Negative b is negative 4. A is 1, so 2a is 2. So it's this is equal to 2. The value is, the minimum value is f of 2. You find the place and you evaluate the function at the right place. So 2 squared, 2 times 4 and times minus 5, right? So it's equal to -9. So the minimum value is -9. It happens at 2. It occurs at 2. Okay, so here we finish the section of quadratic functions. You know the vertex, the axis symmetry, you know the, so the same thing, still the same thing, those 5 stuffs: vertex, axis of symmetry, increasing, decreasing, max mean value, and xy intercept. That's all the important quantity, all the information about the quadratic polynomial. And the summary is on page 296. Okay, do the exercise and do it by yourself. Okay, we'll stop it.